Hi, welcome to RVC Talk. Let's have a quick discussion on a board support package. Now, what is a board support package? It is a set of software used to initialize the hardware devices on the board. So, this will implement board specific routines that can be used by the kernel and the device drivers. Now, it's a hardware abstraction layer gluing the OS by hiding the details of the processor and the board. Now, board specific routines are basically a typical hardware abstraction layer for the board hardware. So, it is going to be different for different boards with a different hardware. Now, the same board which has a different hardware connected to this, and another board, another same board with a different hardware connected to this will have a different package. Now, so board specific routines, which are a common, we will discuss on more on a common routines, which are on any board will exist, so that we'll have a fair idea on what is actually board specific routines or BSP, right? So, a typical HAL for the board hardware include a bootloader interface. I'll just go to the next one. So if you see, the BSP contains a bootloader interface, a memory map, system timers, an interrupt controller, real-time clock, debug and console, bus support, power management. These are the default functionalities of any BSP package. Now looking at one by one, what actually bootloader interface will do. So bootloader interface is a piece of software that runs executing immediately when you power on any board, right? So it has two major functionalities. So one, you can call it as basically the functionalities can be classified into two parts. It's a mandatory and optional functionalities. So the mandatory functionalities are nothing but initializing the hardware. So I'll just go. So basically, when you switch on a board, so the bootloader interface will make it will switch on the initializing, basically it is initializing the hardware, loading the kernel, passing the necessary information from the bootloader to the kernel. So these are the mandatory functionalities. Now, when it comes to the optional, so these are actually highly customizable and where it depends on uh, customer usage. So suppose if I want to connect in a different hardware, now that particular thing need to get started before other hardware. So I do that customization. I prioritize that part of the piece of the code to be run first compared to in basically instead of other routines. Now I do that customization that is an optional, which is specific to a board, which is specific to a user requirement. Now, going to the next part, right? The memory map. Memory map is the this is a critical thing which is actually defines the overall layout of the entire address space. Who is going to do? Who is going to use what? Right now, the layout of the CPU address entire space will be allocated depends on who is going to use, right? So the memory map is needed to freeze the addresses. Memory map is needed to freeze on the address space allocated for various hardware components. It will have a complete picture of a memory allocation to various software components, such as bootloader to the kernel and who is going to use what. Right. Overall creation of the memory map you can actually classify into three parts. One, the processor. Basically the first the memory map that need to be created basically to highlighting okay or to allocating some part of the memory for the processor. This will clarify the CPU memory management policies, like how CPU handles the user mode, kernel mode. All these will be taken care as part of this. Now the second part comes into the board memory map. Now, this requires an understanding of the various onboard devices. So, what are the hardware connected to this? Now, each hardware, how much basic minimum memory it required, or a bus controllers, what is it basically it's going to use, what the address space. So, all these basically in a developer need to have a better complete understanding of this, and how the process sees the different memory areas need to be defined, and that memory areas need to be allocated. That's a board memory map allocation, right? The third thing is a software memory map. Now a portion of the memory that need to be given for various software components such as a bootloader, kernel, etc. The kernel sets up its own memory map again inside that and decides on a various kernel sections such as like code, heap, how, where it will use this particular memory. Now, coming to the next one is interrupt interrupt controller, right? So how it is going to manage interrupts? Every board is unique with interrupt management. So it will have a lot of different interrupts based on how we are going to use, what are the hardwares connected, and what is the priority hardware, which one should be prioritized, like this, right? So now kernel treats all interrupts as a logical interrupts. Logical interrupts are directly connected to the processor via programmable interrupt controller. That's we call it a PIC. That is where we actually write a lot of code on highlighting the prior, basically, changing the priorities of these interrupts and which one need to get priorities, which one will be in a lower priority, all these things. Now coming to the timer. Now if I see the timer, overall two types of the timers that need to be programmed by BSP. Now, what are the two types? One is a programmable interval timer. This timer is hooked to the timer interrupt that provides a system pulse or a ticks. Now, the second thing is the real-time clock. Now, what is actually real-time clock or board? Now, this is an independent of the processor as it is external chip on the board. So basically, that is where we actually put a battery. Or if you okay, the real-time clock is operated by special battery that powers it. So that is the reason why when even though we switch off the board, so the timer keep running. So basically when you switch on, you will be able to see the timer, right? So that is how a lot of different non-mandatory services, timing services, daytime services, all these can be actually provided with this the real-time clock. Now the third thing is basically, I'm going to talk about the power management first. Now power management is nothing but the different embedded devices have a different power requirements depending on the usage. Example, like we are using a cell phones today. Cell phones will have very low power consumption requirement. So the battery life is very important, right? So the different policies required to enforce the different power management depending on the need, right? So these are the two important things. One is basically a dynamic frequency scaling. Second thing is a dynamic voltage scaling. So these frequency scaling and dynamic voltage scaling we will discuss in a different video. Now debug and the bus support. Now debug is nothing but basically it provides an interface for us to the debugging on the board during the development and all. Now in terms of a bus support, so you can actually connect an SD card or a USB cable. So all these is basically an external hardware you are connecting, and the board support package will take care of supporting those things. So now typically if we look at the how the board looks up, right? So these I just taken an example of the QNX board. So if you see the summary, right? So what all it provides as part of this is actually the same whatever we discussed in terms of debugging UART, I2C bus driver, a wide Ethernet driver, dual USB host resource manager in terms of connectivity. External storage is nothing but the SD card, eMMC card, or different file system support, and graphics, multimedia, audio is basically the display controllers. So so these all are supported as part of this, and this is what basically you do the customization based on this board, what hardware you are connecting, and how do you want that to be function. So the entire thing is actually you will modify, write the libraries, or develop, build it, and load it onto the board. So that is nothing but in a core BSP functionality is all about, right? So if we quickly go through what are the kind of questions anyone will ask as part of your interview or a technical discussion. So is a BSP customizable? Is the first typical question, right? So, what kind of a customization you have done, and what are the tools you are using as part of the BSP customization, right? What are the primary functionalities of the BSP? So, okay, if you look at the BSP file system, it has so many different directories, it has so many different files, right? So there are a lot of questions, especially on basic elements, standard files present in the BSP, in addition to the default files. So it is in a generic questions, but we'll make a separate video more on with questions and answers for BSP interview related thing. Thank you very much for watching.